squared over 36 plus y squared over 9 equals 1. Why? Because we need to graph this. We always need to graph to see what's happening here. I know sometimes it's a hassle, but we need to do that most of the time. I wouldn't say 100%, but most of the time. So this is a squared, which is 36, which means a equals 6. And this is b squared, which is 9, which means b equals 3. So the graph will look like this. 6 left and right. Oops. And 3 up and 3 down. Of course, my graph is not perfect. It will never be perfect. So this is 3, this is -3, this is -6, and this is 6. And this point 12, 3 is somewhere here. And obviously 1, but you should not think in those terms. 1 of the tangent is this, which will definitely be y equals 3, but I don't recommend you do that. You write anything yet. And the other tangent will be this. So there is a system that we have to solve. So first of all, we have to denote this point as x comma y. And then we will have to create the slope x comma y to this point. I'm going to call this a and this b. So the slope ab, first of all, is 3 minus y over 12 minus x. But this is also dy over dx when x is x and when y is y. So just dy over dx. So how do I determine dy over dx? Well, implicitly, because y depends on x. And I can solve this, right? I will get 2 pieces, but there is no need to solve. I just need to find dy over dx. And from here, this will be one equation. So we have this explanation. I'll send you the video with what's happening next. But this is the idea.
Okay,
It's a problem that requires several steps and about 10 minutes or so. There is nothing there is no way I can put a problem like this on a test. I'm testing basic things.
Oh, okay.
Because
I was a little nervous when
this will take you know, I'm not testing one topic. I can't test one topic. So
right.
I have to test a variety of topics, and this will take 10, 15 minutes, and I don't want any problem to take that long on a test. But I'll send you the video and the links to the video and when we had this in class.
Okay, thank you.
Thank you. Okay, next question. Is there anything else before we start our review? Anyone has other questions for us? So does anyone remember doing this problem in class? Anyone? Okay, at least I got one yes. Thank you. Okay, so if you don't have questions, then I would like to start my review. And I made a list of questions that I wanted to look at. Would you like to start from 311 and go backwards? So this is the list that I made for myself: 3.1, 3 problems, 3.2, we're going to go over all of them, and hopefully 3 problems in 3.3, 1 problem in 3.4, and so on and so forth. So let's start from backwards, because these are just, you know, applying differentiation rules, but I think we should go backwards to have time for the more involved problems. Is that okay?
Yes.
Okay, so I'll start with, feel free to choose, right? At any point in time, you can choose. So let me go to the book. Where is my book? I thought I opened, oh no, I didn't, because the problem was, I remember, I got logged out. What a nerve for them to log me out, but they did. Okay. Again, 3.1143 caught my eye. But again, if you have any preferences, let me know. I don't even remember why right now I chose this, but 43. Okay, so this was on hyperbolic functions. And the problem is only asking us to find the derivative. We can skip this one if you want to choose a different one. I only request the hyperbolic functions, not the inverses. If I put an inverse, which I won't, I will have to give it a formula. Is this okay, or do you prefer something else? Not the inverse hyperbolic functions.
I'm good with that one.
Okay.
That one.
Okay, fine. So then y equals hyperbolic secant times hyperbolic tangent. So when we look at this problem, what is the first thing we should think of? The fact that it is what? It's a function. Say it again, sorry.
A product?
Yes. So it is the product. So I have to remember to apply the product rule. I chose a secant, hyperbolic secant, but I will probably stick with sine, cosine, and tangent hyperbolic. Okay, so knowing that this is the first function, the second function, y prime will be hyperbolic secant prime is negative hyperbolic secant times hyperbolic tangent, of course, times hyperbolic tangent, and then plus hyperbolic secant, and hyperbolic tangent prime is hyperbolic secant squared. And you don't have to do anything else. You can, if you'd like to factor out, then maybe it's simplifiable, but I'm fine with that. Okay. Next one. Let's go back to 3.10. So again, just simple differentiation for hyperbolic functions. Now, one quick question. If I want to evaluate this function, so let's say I want to evaluate this function when x equals 1, how will I do it? Or let's say even easier. What if I have a function that is hyperbolic sine squared, and I want to evaluate when x is 3? How do I do this? Any suggestions, anyone? I don't think the calculator, yes, go ahead.
The chain rule?
No, just to evaluate.
Oh, just to evaluate.
Just to evaluate. So let's say this is f of x. So I want to find f of 3. I could be asked to find f prime of 3. But how do I do it?
You sub 3 into the equation?
Yes. So how do I determine this? How do I find hyperbolic sine of 3 and squared? How do I find this? So careful, I don't think the calculator has hyperbolic sign or any hyperbolics. I didn't find it. If you find it, that's fine. Let me know, teach me. So what I have to do here is write e to the third minus e to negative 3 divided by 2 and then square this with a calculator. Now, if you find this function in the calculator, please let me know. If not, you have to know that what the sign, hyperbolic sign, looks like. So please remember to have hyperbolic sine, hyperbolic cosine, and hyperbolic tangent, and their definitions. Okay, back to 3.10. So in 3.10, I selected, again, feel free, I selected 36, 19, 36, and 43. So let's take a look, and you tell me if that's okay. So 19 was this. Find the differential and evaluate it. If you think it's too easy, we can choose anything else or just skip it. Then I chose 36. This I have to show you anyway, even if you don't like it. No, I'm kidding. I want to show this. And 43. 43 is this, the circumference of a sphere. Any preference? Is 19 okay?
19 works.
Okay, so in 19, in 3.10, we have y equals e to x over 10, x equals 0, and dx equals 0.1. So they want us to find the differential dy first, and then evaluate it for the given values. Fine. Can anyone give us the general formula, just the formula for dy, for any function? For any function f of x.
The function prime dx.
Very good, awesome, thank you. So it's f prime of x dx. So when I differentiate this function, I get e to x to 1 over to e to x over 10 times the inner function prime. So 1 over 10 e to x over 10, and if I forget dx, then I'm not determining the differential of y. So now when I plug in 0, this is 1. When I plug in 0.1, it's 0.1 over 10, so this is 0.01. Any questions on 19? Is this okay, everyone?
Yes.
Okay. So let's continue with 36. And 36 is still in 3.10. What was it? I think it was cosine 29 or something. Okay, very good. Cosine 29 degrees. Perfect. Okay, so remember the delta y is approximately dy. From here we build f of x plus the error is approximately f of x plus dy, which is f prime of x dx. So remember in this situation, what we have to determine is f of x, x, dx, and of course eventually f prime of x. Once I have identified all these, all I have to do is just plug it in and get a number. So let's start with the function. Can anyone tell us what function are we looking at?
Cosine of it.
Very good, awesome. So then immediately I can find f prime of that function. I know you all know it's negative, negative sine x. Good, now let's identify x and immediately dx, because these go together.
X equals 30.
Very good. And -1. Great job, thank you. Keep in mind, dx, it's not inside a trig function. It cannot be replaced by degrees. No degrees. Okay? Only radians. So when I plug in cosine, if I plug in 30 degrees or pi/6, it's not going to make any difference. But when we talk about a quantity outside, it's not inside of a trig function, it's outside, this must be changed into radians. And let me refresh your memory how to change radians from degrees to radians and back and forth. So remember, this is 180 degrees or pi. So knowing that 180 degrees is pi radians, 1 degree, I divide both sides by this number. If I want 1 radian, I divide both sides by this number. So I want 1 degree, or specifically -1 degree, which has to be changed into -pi/180. So this quantity has to be -pi/180, not -1 degree. If it's inside cosine, it doesn't matter if it's radians or degrees, because the answer will be the same, right? Cosine of 30 degrees is the same with cosine pi/6, which is the square root of 3/2. We all know that. Who cares what I have inside of the trig function? No one does. But this is something outside of a trig function. It has to be replaced by radians. So we have everything we want. So then cosine, this piece is this. So then cosine 29 is approximately, and now I just have to follow